Hi, in this video here, we're going to have introductions on how to sketch tangent functions, which in the form of fx equals to a multiply tangent bracket mx plus c plus k. Where in here, the a here is actually referred to the coefficient of the function tangent, and the m here is the coefficient of x. C and k is just some arbitrary constant. And to have a better idea on how is the functions looks like according to this form here, let us see some simple example below, where the first one we have fx equals to tangent x, and if we compare with the general function on top, you shall see that the a, which is the coefficient of the function tangent, will be equals to positive 1. Then the coefficient for x will be 1. The c and k is 0 in this case here. For the second case, we can see that the c and k is once again 0. The coefficients of the function tangent is 1 also. Coefficient of x is 2. The third one, tangent 2x minus pi over 4. So in this time here, we will have the constant c appear to be negative pi over 4. Still, the coefficient of the tangent is 1, positive 1. Coefficient of x is positive 2. The next one, if I compare the fourth one with the first one, the difference is just in terms of the coefficients of the function tangent, where now I have negative on the capital A here, which is the coefficient of tangent. And lastly, we have the case that all the A, M, C, K, we have a specific value as reference, where the A is come with coefficients 3, the M negative 2, the C pi over 3, and at last the constant k is 1. Okay, next. Let us go through the remarks that we have here before we go on to the next slide, where first, when the time we sketch the graph later, I would like to have the cycle begin from the point we're taking mx plus c equals 0, where the mx plus c is referred to the bracket here. I'm going to begin from the x value, solve from mx plus p equal to 0. And next, in the graph of tangent functions, it's important to take note that it have a vertical asymptote, it have vertical asymptotes, and you have vertical asymptote obtained based on the calculation where we have a plus minus of n, which n is an integers of periods, add on the x value obtained from the formula mx plus c equals to pi over 2. And in order to further understand what is going on in the statement here, later we shall see from the examples with a specific value, it will be having the better idea. But in general way to state the info, this is what I have. Next, in general, for the domain and range for a tangent function, if it happens to be for domain, it will be all real number, but we exclude the vertical asymptote value. For the range, we will have it infinity to infinity. Then next, refer to the next slide for some of the important terms that will help us in graph sketching. First, I would like to begin with phase shift, similar like for the case of sine and also cos, where this is for us to determine where is the initial point of the cycle, where we have the mx plus c here equals 0. And to have a better idea on where is the phase shift here, let's see from diagram. For diagram, we may have the graph case 1 like this, or case 2, and both of this graph here is the tangent graph for one cycle, and the initial point will be the corresponding point for each of the case that I plot in red here. So this is the initial point that we're going to use for reference in graph sketching later. Then the next thing we need to know is that we need to know the periods of the case of tangent. And in here, there is a slight difference between the periods for the case of sine, cos, and tangent is that for tangent, the period is calculated based on pi divided by modulus m. And this value here is used to determine the length of one cycle of the tangent graph. And for your information, one cycle of tangent graph will happen to be something like case 1 or case 2 here. And the length of one cycle, it will be like what is shown from the slide here. And as you can see from the one cycle graph here, I have a green dotted vertical line there, and this is actually what we have for the vertical asymptote. And the way to calculate the vertical asymptote here is that we're going to begin with solving the mx plus c, the bracket terms here, equals to pi over 2 to get one initial vertical asymptote. And then from this value x solved here, we're going to plus with the periods on it subsequently to get the rest of the vertical asymptote. And once again, to have a better idea on how the calculation is being done here, we will see later in examples. So next, for the sub-interval width, here also we have important thing we call as a sub-interval width, where we find it similar like previously. For sine and cos, we have period divided by 4, and this is to determine the common difference of x value in the table used for graph sketching. And if let's see, we want to see the sub-interval in the graph, it will happen to be as illustrated here. Next, we will go on with the constructions of the table for the case of tangent, where we will begin the table. We will begin the table with the x value from the phase shift, followed by 4 consecutive x value with the common difference of the periods divided by 4. And in here, please be aware, we will have a vertical asymptote from mx plus c equals to pi over 2 inside the table later. Then once this is ready, we continue with finding their corresponding functions value. Then once this table is done, we begin the graph with a sketch one cycle graph based on the table, and later we extend or reduce the graph according to the domain given. Okay. Anyway, later please be aware on the graph sketching here for the table, where it will be something slightly different from what we have for the case of sine and cos. So next we will go on with the example.